So this is my Lab 3 video report, and Lab 3 is about the magnetic field of a bar magnet. So the main goal of this lab is to see how changes in distance change the magnitude of the magnetic field produced by a bar magnet. We recorded data from various points, including on and off axis points, and recorded the magnetic field. Major concepts that were used include magnetic dipoles, magnetic fields, net fields, and Biot-Savart laws. The physical experiment started with downloading a magnetometer app, which was used to determine the magnitude of the magnetic field from the bar magnet. First, we aligned the phone with magnetic north and the bar magnet with magnetic east-west in order to make the magnet's on-axis field orthogonal to Earth's magnetic field, so we can use only the X component from the magnetometer. We then found the exact place where the magnetometer is located in the phone. This is so we can make accurate measurements about the distance from the magnetometer to the bar magnet. So once we set up our experiment, we were then able to measure the magnetic field at several different on-axis observation points. We used these points to create a model that found the distance dependence exponent, which is n, and the magnitude of the magnetic field. An important observation that we made is that as the magnetometer moved closer to the magnet, the magnitude of the magnetic field in the x direction increased. So as you can see, our Excel program takes in our observed values of the magnetic field and distances and plots their natural logs. Taking the line of best fit to this curve, we can use the slope to find the value of n, which is negative 2.2. It makes sense for this exponent to be negative, as the magnetic field should decrease as distance increases. This is my GlowScript code. It produces the expected magnetic field from our physical system. In line 11, you can see we use the Biot-Savart law for calculating magnetic field. And this is the model that code produces. The blue arrows are perpendicular magnetic field, and the purple is the diagonal magnetic field. So in comparing the experimental with the predicted, our experimental data has an outcome of 0.00017 Tesla, and our predicted value is 0.00013 Tesla. These values are the same power of 10, so I would consider both to be reasonably comparable values. So question 1 asks, what if we hadn't oriented our experiment to compensate for magnetic north as I described, and had instead laid out the meter stick at some intermediate angle with respect to Earth's magnetic field, and how our results would have changed. First, I wouldn't have been properly able to locate the magnetometer within my phone. This would alter distance measurements and render them inaccurate, and therefore affect final data. I would also be unable to tell if the magnetic field is coming from the Earth or the magnet, further altering the data. The second question asks what if we were to stick two identical magnets together end to end and run the experiment again, and what changes? So I would expect the magnetic moment of the magnets to increase. Due to this, the distance at which the magnetic field equaled the desired values would be increased. Thank you.